All right, so what you're seeing in this graph, in this picture, is one of the, if you will, dirty little secrets about confidence intervals. See, whenever a news person gets on the news, they always say, oh, so-and-so's approval rating is this, and, the percentage of Americans who think we're on the wrong track is this, and blah, blah, blah. And they act like it's so given, and that everybody knows that that's what it is. So, for example, in this one, they'd say, the beads in that box are, well, for example, 25% red or 38.8% red. That's what they are, as if that's what it exactly is. But the kicker is that when they tell you that, they have no idea if the 30.8% or the 18.3% or whatever it is they're saying is actually right. They're only 95% sure that it's right. Okay? So that means that 5% of the time, the number they're giving you and the interval that would result from that don't actually contain what it really is in real life. Let's just let that sink in for a second, right? 95% of right, so let's put it this way. If you're working, as most news organizations are, with 95% confidence intervals, that means only 95% of them will actually contain the true proportion, population proportion. In this case, it was P equal to 20%. So when they say, like, I don't know, what percentage of people are going to vote for McCain in the next election or something like that. They obviously not the next election, but bear with me. So what percent? They say, oh, it's 30.8%, Bob. Oh, really, Tony? Blah, blah, blah. But they don't know that. They are looking at the center of these intervals and acting like that's what it is. Half the time, they don't even tell you that it's really 30.8% give or take something, right? And you have to search to find the give or take in the little small print. And then they won't even bother to tell you what confidence level they had, although generally it's 95%, which means 5% of the time the numbers they're reporting don't actually contain the true proportion if you've filled out the interval. And you don't really know where it is. That's huge. That's a really big deal, and you really need to pay attention to it. This means 5% of the time the interval will not have P. Okay? And on top of it all, you don't get to know. So normally when you do this for a sample or a poll, you don't poll 50 majillion times. You poll once. And if you just happen to be this one sample got the 30.8, then sorry, that's what you got. You don't ever get to know that you were that off. The only time that you'll figure out that you're that off is presidential elections, honestly, because this is like week 1, week 2, week 3, week 4, and they'll keep going and going. And so you'll see, like, oh, okay, overall we can see a trend, and this one week was an outlier, right? But in general, you don't get to know whether your one scoop was an outlier or not. If I polled JCC students tomorrow about, I don't know, getting rid of spring break, I would have no way of knowing if that poll that I did, which is nice and random, was one of the ones that actually contained the proportion or one of the ones that didn't. Scary, huh? And yet decisions get made on them all the time as if they're 100% accurate and 100% true. Because, of course, at some point you have to make a decision. But the kicker is that a lot of people don't understand that when you make those decisions based off of those intervals, a lot of people don't realize that you don't know whether it's right or not. All right, I'm off my soapbox now. So in a class that had 25 students that took the beans from the bin and counted, how many different intervals would we create? Well, 25, right? Because we'd have 25 different students. So how would that affect the graph above? Well, let's see. 25 times 0.95, which is 23.75 of the students would make intervals that contain P equals 0.20, because that's what it really was for that box. And 1 to 2 students would be out, would not have P equals 0.20 in their interval. All right, I'll stop right here.